So, I want to talk about a really compelling new paper today. It's one that, well, it directly challenges some of the most dominant ideas in AI safety, especially the heavy focus on existential risks from some future superintelligence. It argues for a totally different framework, one they're calling normal technology. And they pull from history, engineering to propose a whole different way forward for governing this stuff. So, yeah, let's really get into the core of their argument. At the very heart of the whole AI safety debate is this one fundamental question. Are we building a new kind of mind, almost like a new species, or are we just building a much, much better tool? The paper argues that how you answer this question completely changes your approach to risk and governance. And, they say, the dominant story so far has leaned way too heavily on that new species idea. So the paper really frames this as a clash between two different worldviews. On one side, you have the one we all know, the superintelligence view. This is the idea that AI is on a path to becoming this autonomous, godlike, totally uncontrollable force. But the authors want us to look through a different lens, the normal technology view. This sees AI as, yeah, an incredibly powerful tool, but one that's ultimately controlled by humans and is manageable, just like other huge technologies that came before it. Now, when they say normal, they don't mean weak or unimportant. I mean, electricity was a normal technology, and it completely changed everything. Their crucial point is that AI is a technology that follows predictable patterns of adoption and integration into society. They're not just describing AI as it is today, they're making a prediction about its future and offering a prescription for how we ought to be governing it. Okay, so that leads us to their first major point, speed. We hear all the time about these fast takeoff scenarios, right? Where AI capabilities just explode almost overnight. But this normal technology view, it predicts something completely different. A slow, decades-long process they call diffusion. The authors break down technological impact into these four stages. We in the tech world get super excited about stage one, the invention, a new model like GPT-4 drops, but they argue that the real-world impact is held back by the much slower stages of innovation, adoption, and especially diffusion. And each of these handoffs has massive real-world speed limits that just get ignored in those fast takeoff models. And this is just a fantastic historical parallel. When electric dynamos were invented, everyone expected this immediate, massive boom in productivity. But it took almost 40 years. Why? Well, because you couldn't just drop a new electric motor where an old steam engine used to sit. Nope, you had to completely redesign the factory, the assembly line, the entire workflow. That kind of deep societal change is just incredibly slow. So you might look at a chart like this and say, wait a minute, Gen AI adoption is way faster than PCs were. But the paper argues this is a really misleading way to look at it. This chart measures casual use, not deep integration. The real difference maker for the PC revolution was the intensity of use and all the costly, painful business reengineering that came with it. And for AI, that process has barely even started. This brings us to the paper's next big argument. The authors say that our obsession with intelligence as the main metric is actually a huge distraction from what really matters here: power and control. We've all seen this kind of chart, right? This one-dimensional line of intelligence that pretty much frames AI as our inevitable successor. The paper argues this whole model is just fundamentally wrong. But the paper asks a really critical question. Is this even the right way to be thinking about this? Is intelligence really the thing that defines our place in the world, or is it something else entirely? And here's their big reframing of the whole issue. The difference between an ancient human and a modern one isn't some huge leap in our biological brain power. It's our technology. Our power comes from augmentation, from tools. And from this point of view, AI isn't a competitor on some intelligent spectrum. It's a powerful new tool for us to wield, something to extend our own capabilities. So if AI is just a really complex system, the paper argues, then we should be using the huge toolkit we already have from systems safety and cybersecurity. We shouldn't be searching for some brand new science of alignment. They're saying that concepts like fail-safes, redundancy, and the principle of least privilege aren't just kind of useful, they are the main proven ways to manage the risks of powerful, unpredictable systems. All right, so this normal technology way of thinking leads to a totally different perspective on risk. It shifts our focus away from a rogue AI that spontaneously decides to kill us all and toward the very real ways that humans might misuse it, or frankly, just build it badly. The paper makes this really important distinction between what it calls stochastic and speculative risks. Stochastic risks, like nuclear war, have a known non-zero chance of happening. But speculative risks, they have what's called epistemic uncertainty. We don't even know if the risk is physically possible. Its true probability could literally be zero.
And this leads to one of the paper's boldest claims, that the famous paperclip maximizer scenario and other X risks like it are speculative risks. They argue these thought experiments are actually terrible guides for real-world engineering because they make some really questionable assumptions about how things get deployed.
So, why would it fail? Well, because technology doesn't just appear in a vacuum. Long before some paperclip AI could ever get its hands on global resources, it would have to pass thousands of small, low-stakes tests. I mean, any system that interprets "get me a coffee" by smashing through a wall would be shut down and redesigned immediately. The real world has all these built-in safety checks, from simple user feedback to complex financial and regulatory rules that would filter out this kind of catastrophic, literal-minded behavior. So if a rogue AI isn't the main threat, then what is? The authors argue we should be way more worried about these systemic risks. And these aren't sci-fi scenarios, these are just magnifications of problems we already have in society. AI as a tool used by powerful institutions to entrench bias, to concentrate wealth, to erode democracy. This, they argue, is the real, the present, and the growing danger. Okay, so what does this all mean for policy? If we buy into this framework, it points us toward a very different way of governing AI, one that's less focused on stopping a hypothetical superintelligence and more focused on managing a real-world technology. This table breaks down 4 common ways we govern technology. The authors argue that trying to predict all of AI's risks ahead of time, what's called the ex ante approaches, is basically impossible for a technology this general purpose. Instead, they champion resilience, which is a hybrid approach that gets society ready to adapt to shocks and failures when they inevitably happen. And resilience, in this case, isn't about preventing every single failure, because that's impossible. It's about building social and technical systems that are strong enough to absorb shocks, whether they're from accidents or from attacks, and then recover without the whole system collapsing. The goal here is to ensure a soft landing. And this really sets up the core policy dilemma. The superintelligence view naturally leads to a non-proliferation mindset, treating AI like a nuke that has to be centrally controlled, licensed, and kept in the hands of a few responsible actors. The resilience view argues for the exact opposite, decentralizing our defenses, encouraging competition and openness, and building a robust, diverse ecosystem that isn't vulnerable to one single point of failure. The authors go hard on this, arguing that the whole non-proliferation approach, which often looks like calls for licensing or centralized control, is dangerously counterproductive. They say it's not just impossible to enforce globally, but it also creates these software monocultures where one single exploit could be catastrophic. And, crucially, it stifles open safety research and stops us from using AI broadly for defensive cybersecurity, which could paradoxically make us even less safe. And that leaves us with this final, really provocative question. If AI is just a normal technology, are we preparing for the right future? By focusing so much of our energy on the speculative risk of a rogue superintelligence, are we diverting our attention, our resources, and our policy away from the very real systemic harms of normal AI that are happening right now? This paper argues that yes, we are, and that a major course correction is needed.